Welcome students to today's session. In today's session, we shall study image formation by a convex lens. When an object is placed at infinity, the image is formed at f2 focus, that is, on the other side of the lens as the object. The image is, since it's a converging lens, converges the rays of light, and the image is formed at focus on the other side of the lens. The image is highly diminished or point sized, real and inverted. So this is the first ray diagram. Let's move on to the next position. An object placed beyond 2f1. The ray of light parallel to the lens after refraction passes through focus on the other side of the lens. We'll take another ray, the ray which is passing through the optical center. It goes unrefracted, that is, it does not show any deviation, and we get an image between f2 and 2f2. Let's put the arrow mark. So the image that is formed is between f2 and 2f2. The image is diminished, it is real and inverted. Let us move on to the next position. Object is placed at 2f1. The ray that is parallel to the principal axis passes through focus. The ray that is passing through optical center passes undeviated. Draw the arrow marks. This is undeviated. See, the image is formed at 2f2. Let us see the characteristics of image. It is same size as the object. It is real and inverted. Let us move on to next position. Object placed between 2f1 and f1. The ray of light that is parallel to the principal axis passes through focus on the other side of the lens. The ray passing through the optical center moves undeviated. Complete the arrow marks. Get the position of the image that is formed. The image is formed beyond 2f2 and the image is enlarged, real and inverted. Let's move on to the next position. When object is placed at f1, the ray of light parallel to the principal axis passes through focus and the ray passing through optical center moves undeviated. Let us complete the arrow marks. Now look at this particular ray diagram. Both the rays are parallel, so there is no image formation along the arrow that is below the lens, or we cannot have image formation in immediate vicinity on the other side also. So this is where both the rays run parallel and the image is understood to be formed at infinity. So the image is supposed to be highly enlarged, real and inverted. The image is formed at infinity. So these are the characteristics of this particular ray diagram. Let us move on to the next ray diagram. When the object is placed between f1 and optical center. Ray parallel to principal axis, under refraction passes through focus. Ray passing through optical center moves undeviated. Now again, we cannot have an image on this side of the lens. So the image is extended, the rays are extended backwards. The image is formed on the same side as the object. Let us see the position of the image. Extended backward, the image is formed on the same side of the lens as the object is placed, the image is enlarged, virtual, and direct. So these are the properties of the 6-ray diagrams for the convex lens. Let us consolidate this and look at this consolidate image formation by a convex lens. When the object is at infinity, image is formed at f2, highly diminished, real and inverted. When the object is at 2f1, image is between f2 and 2f2, diminished, real and inverted. When it is at 2f1, the image is at 2f2, same size, real and inverted. Between 2f1 and f1, the image is at 2f2, enlarged, real and inverted. When the object is at f1, the image is at infinity, highly enlarged, real and inverted. The object is between f1 and optical center. The image is formed on the same side of the lens, enlarged, virtual and direct. So with this, we end today's session.